Dear students, I am Mahesh Javalkar from Maratha Mandal Polytechnic, and today I will be starting with a new subject called as Applications of Electronics Engineer for fifth semester students. And let me start with the first unit, which is Consumer Electronics, which will consist of all the consumer electronic appliances. And in that, first, what we are going to study will be a calculator. Okay. Now, here, students, we are having a book called as Applications of Electronic Engineering, which is based on fifth semester diploma electronics and communication, which is written by T.G. Katewal, HOD of ENC Department Hulkoti Polytechnic, and myself. And this book is according to the syllabus what is there for fifth semester or diploma ENC in this subject called as Applications of Electronics Engineering. So this book consists of all the 6 units what you have in your syllabus. The unit one is called as a consumer electronics, in which you will be studying various types of consumer electronic devices. Unit 2 will be automobile electronics, where you will be studying about electronics related to an automobile. Then you will be having audio systems, where sound systems you are going to study. Then you will be having video systems, where the picture systems can be studied. Then you have fifth chapter as entertainment electronics, where all the electronic devices which are based on entertainment will be studied. And then you will be having sixth and very important chapter called as robotics, where you will be studying the basic fundamentals of robotic engineering. Okay, so all these six chapters are covered in this book, which is called as Applications of Electronics Engineers, EPPB are publications, and which is written by T.G. Katewal sir and myself. Okay, then we'll go to this presentation. So in this presentation, I have taken what do you mean by consumer electronics, define calculator, structure of a calculator, types of calculators and their applications, internal organization of a calculator, how a calculator works. Okay. Then if you see the definition of consumer electronics, so what exactly we mean by consumer electronics? Consumer electronics refers to any device containing an electronic circuit board that is intended for everyday use by individuals. Okay. Now, like for example, we have a television, we have a camera, digital camera, PDAs, calculators, VCRs, DVDs, clocks, audio devices, headphones, tablets, smartphones, and many other home products like your micro oven, washing machine. Okay? Now, all these come under consumer electronics. These are electronic devices which are used by the consumer, by the people, by the normal people in their daily life. Okay. So it is day to day life what we use the electronic appliances come under what is consumer electronics. Okay. So, in this subject, we are going to study the first a consumer electronic appliance that is simple calculator. Clear? Then we'll go to see what is an calculator. An electronic calculator is typically a portable electronic device used to perform calculations. Okay, these are arithmetic calculations like your addition, subtraction, multiplication, division, which range from basic arithmetic to complex mathematics. So you can have your simple calculators also. You can have scientific calculators also. Okay. So you can this calculations what we have are ranging from basic arithmetic like your addition, subtraction to complex mathematics where you can have trigonometric functions, exponential and other things. Okay. Then we'll go to see the structure of a calculator. Okay. Now here in the structure of a calculator, the first thing what we have is the input device. Okay. So the input device will be like a keyboard, okay? And on that you have your numbers which you can press. And once you press any key, that number will be stored in the memory of the calculator for the operand, which can be used further in the arithmetic unit. Okay. So here, the most commonly used input device will be your keyboard. So here you can have your keyboard as a input device. Okay. This is an example. So keyboard, you press any key, any number. If you want to say do addition, 5 plus 8. So you have to first press 5, then you have to press plus sign, then you have to press 8, then you have to press is equal to. So all these keys are on the keyboard and that will be the input device. Okay. Then you have a data storage. Now data storage mainly in the calculator is in the form of registers. Data storage is in the form of registers. So registers are devices which can store data. They are made up of flip-flops. Okay, so they can be used to store data. And now here, whatever key you're going to press from the input device, that will be stored in the data storage. The numbers which you're going to use as operand and the operation which you're going to use on those numbers. Both are stored in the data storage. Okay. Now, say for example, if you're doing addition or subtraction or multiplication or division, that has to be that has to be given to a arithmetic unit. So here you can see the data, the operand, and everything is given here to the arithmetic unit. The arithmetic unit will process it and gives back to the memory. Okay. All these operations are controlled by the control section. This is a very important section of the calculator, which is a digital section which will control the controlling of the arithmetic unit and the memory, the input and output. Okay, so the complete control is controlled by this control section. Then once your answer is returned back to the data storage registers, then it has to come out to the display device. Here it will come out to the output device, which is called as display device, which can be a LED display or which can be a LCD display. Okay, so then it's a simple thing. You are going to give input operands and input operation, whether the operation will be addition, subtraction, multiplication, or whatever it is. And that input operands and operation will be stored in the memory. Then they are going to be processed in the arithmetic unit. Once the arithmetic unit processes it, it will give the result back to the memory. Then the memory will give it back to the output device where the result will be displayed. Okay, all this general type of function will be done with the structure of a calculator. Okay, now with this we'll go to see the next one, types of calculators. Now, in types of calculators, there are many types of calculators, but a few we have taken here. Number one is basic calculator. Number two is scientific calculator. Number three is a graphing calculator. And number four is printing calculator. Okay. So if you see basic calculator, it will be a simple calculator where you can do addition, subtraction, multiplication, and you can store in a memory and you can fetch from the memory. You can also have some root x or so in that only simple or commands of arithmetic, then that is called as a basic calculator where you are doing simple arithmetic functions. Then similarly, we'll be having next a scientific calculator where some extra features of mathematical operations have been added. And there you can have your square root, you can have your trigonometry functions, okay? Then you can have your radians, okay, roots, powers, okay, exponents, factorials, etc. All that you can have in a scientific calculator. Then third, we can go to see what a graphing calculator. Okay, so it is a calculator which is capable to plot graph, solving equations, angle measurement, complex numbers, fraction, etc. All that will be done in a graphing calculator, which where you can plot a graph of the parameters whatever you're going to store. Then we will have something called as printing calculators, where you can get a mini printout at the output of the calculator of whatever task you perform on the calculator. Okay. So these were some of the types of calculators. You have many other types are also there, but few we have taken here. Then we'll go to see the internal organization of a calculator. So after seeing the structure of the a calculator, we will see the internal organization of the calculator. So internal organization says that first you are having a keyboard here. So this keyboard will be having keys which will be having your numbers and operations, whatever is there. Once it is pressed, once it is pressed, that will be encoded by the encoder. Means whatever you're going to press, it should be understood in machine language. Whatever you're going to press, say if you're pressing a number 5 and the number 5 is a decimal number, then it should be converted into a BCD number in ones and zeros, so that 1 will be taken as plus 5 volt, 0 will be taken as 0 volt, and that will be given to the control unit. Okay, so that will be understood by the control unit what you have entered. Okay, and also operations like addition, subtraction, multiplication, all that have to be encoded, because every operation will be having its own operational code which the control system will understand and direct the uh, addition subtraction unit, that is the arithmetic unit, to do that certain performance. Okay, then you have something called as instruction register here. Instruction register which will understand what type of instruction you are going to do, whether it is addition, subtraction. Then you have address register which will give you the address of the memory from where the data has to be taken. Then you have a read only memory here which will be having certain functions. Then you have a clock on which speed the digital control unit is going to work here. Then you have a power supply here, which is going to give you the power on which the calculator will work. It can be a cell, it can be a solar cell, anything. Then you have here a registers, X register, accumulator, and operand register. So X register is an extra register. This is an extra register. Okay, which will store the operations like whether you are doing addition, subtraction, multiplication, that will be stored in the X register. The accumulator and the operand will have the two operands which have to be operated on, and the answer will be again stored back in accumulator. Then you have a display register which will give the command to the display device. Okay, and then you are having all these scan lines on top. These all are scan lines. This is scan lines, whatever you are having. All these are lines scanning. Then you have a decoder driver plus memory over here, which is again an important thing, which will decode things back which were encoded earlier. Now, after the process, the result has to be decoded back and given to the memory, and from memory, it will go to the display unit. So, here, as an example, we have shown 7 segment display. You can also have LCD or display. And on this display unit, according to your units, tens, and hundreds, you'll be having the display. Okay. So, overall, it is a digital circuit in which the control unit plays an important role. The keyboard or the keypad will act as the input. The input has to be encoded first. It should be understood in terms of machine language by the control circuit. Then, according to what operation has to be done, registers are used, memory is used, okay, and that particular operation is done. And the control unit will be working on a frequency which is given by the clock circuit. Okay, and based on that frequency, all the operations will be done. And once you get the result will be decoded and given to the memory. And from the memory, it will be given to the display unit, where the display unit can be a 7 segment display or a LCD display. Okay, so this is an internal organization of a calculator. If you know the structure of a calculator, then deeply, little deeply, you have to go into the digital circuit, the arithmetic unit, the input and output systems along with memory and control unit. You can understand the internal organization of a calculator. So it is one type of digital system. Okay, Then we will go to see how does a calculator work. Okay. Now most our calculators rely on integrated circuits, more commonly known as chips. Integrated circuits contain transistors that can be turned on and off with electricity to perform mathematical calculations. Then, like all other electronic devices, our calculators work by processing information in binary form. Okay, so whatever we get in a digital, whatever we have in decimal form, whatever numbers we have in decimal form, say from 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, these numbers will be first converted into binary. So it is in a BCD format, zeros and ones. Okay, which means every number or everything, every operation also, once it is converted into an operation, that operation will be converted into an operational code, and the operational code will be converted into binary numbers. Okay, so every number, everything, every function, whatever you are going to have is converted into certain code which is in terms of binary. Then when you input numbers into a calculator, the integrated circuit converts those numbers, binary strings, to zeros and ones. Now, the integrated circuits then use these strings of zeros and ones to turn transistors on and off with electricity to perform the desired calculations. Since there are only two options in a binary system, 0 and 1, these can easily be represented by turning transistors on and off. Since on and off easily represent binary options, on means 0, off means 1, or vice versa. Okay. Once a calculation has been completed, the answer in binary form is then converted back to our normal base 10 system so that normal person can understand what the operation has taken place and what is the result. And it is displayed on the calculator's display screen, which can be LCD or LED. Okay. So here, students, in this our calculator is, it is very simple. First, say for example, if you want to do some operation like 8 plus 2, then first you have to press a number 8. Now the number 8 will be converted into your binary number, that is the BCD number, and it will be stored in one operand register. Then the addition sign plus will be having a certain code that will be also in a binary form, and that will be stored in the X register, extra register. Then your accumulator will have number 2, the next operand, and that will also be converted into binary number, and it will be stored in the accumulator. Then 8 plus 2 will be understood by the control circuit, and the operation will be performed by the arithmetic unit. Then that addition will be done and the answer will be stored back into accumulator. Then from accumulator it will go to the memory, and from the memory it will go to the display device, and on the display device, whether it is LED or LCD, a number 10, that is 8 plus 2 is equal to 10, will be shown, because after you press is equal to sign, again is equal to sign also will be decoded into binary, and then that binary number will be understood by the machine, by the control unit, and then it will understand that the answer has to be shown on the display unit. Then 8 plus 2 is equal to 10. So 10 will come on your display unit. Okay. So this was the first part of my applications of electronics engineering fifth semester diploma subject. In the first unit, the first appliance, what we are going to study was a calculator, and I have given you a brief introduction of this first unit. So please go through it. If you are having any doubts, you can ask me. Thank you very much.